Our focus in this video shall be on the chemistry of lipids. That's what our focus will be on. So when you're talking of lipid, you are talking of the starting from the simple ones like fatty acid, then you keep moving till you get to terpene, you get phospholipid, waxes, sphingomyelin, so and so on and so forth like that. Those are lipids. Now, what are the essence of lipids in our body? You know, lipids are very useful. They have various use in the body. So, for example, they serve as metabolic fuel in the body. They serve as fuel. They serve as energy storage. They help to store energy in the body. So that's in the form of triglyceride, or you call it triglycerol. So they store energy in that form. A lot of energy are stored in triglycerides. So that's one of their uses. So another one is they form the major component of the cell membrane. That's the work of phospholipid. Now, you know, phospholipid is one of the major component of the cell membrane. So that's what it does. So another importance of the lipid in our body is that they serve in various cell signaling process, and you know, they serve as chemical messengers. Are you getting that? It is in form of steroid hormones. Like steroid hormones, now they are lipids. So you know, they help to carry information around the body. So they are of very great importance in the body. So now let's move. So I mentioned something earlier that when you're talking of lipid, you are talking of fatty acid, you are talking of prostaglandins, you are talking of terpenes, you are talking of waxes. What other example can I remember? Okay, you are talking of triglycerides, you are talking of phospholipids, so you are talking of fatty acids, so and so on like that. So let me first start with the fatty acid. You know, fatty acid is the simplest of the lipids. It has the simplest structure of the lipids. Now, when you're talking of fatty acid, the structure, you know, okay, generally, let me talk. Generally, fatty acids they are hydrophobic. Are you getting it? Because that is, they are insoluble in water. They don't like water. They are insoluble in water. So that's the general property common to all fatty acids. So saying that, sorry, I mean lipids. So saying that, let's move forward. Now, lipid. Let's talk about the. You know, we have some examples of lipid. We have the saturated or unsaturated lipid. So then we have the monosaturated lipid, unsaturated lipid, or diunsaturated lipid. So it depends. So now when you say something is unsaturated, from the basic organic chemistry, you know, it doesn't possess that means it has double bonds. So now let's go. Let me give you an example of some fatty acids. So one is an example is lauristic. Okay, lauristic acid. Lauristic acid. Okay, now let me to make it so it has the formula. So this is the formula of lauristic acid: CH3 CH2 7COOH. This is the formula of lauristic acid. Then myristic acid. So it has the formula. Oh, sorry, this CH2. Then so there CH3 CH2 12 COOH. Then we have palmitic acid. So it has the formula CH3 CH2 14, then COOH. So it goes like that. Now note the difference. You can see this one is having 10, 12, 14. So this one altogether is made up of 18 carbons. So that's 10 here. Okay, sorry. I mean 12 carbons. So 10 here, 11 here, 12. So you count together 12. Why this one is 14, this one is 16. So it goes on like that. So let's talk of lauristic, myristic, palmitic, then stearic acid. So the same, it follows the same pattern. CH3, CH2, 16, then COOH. So finally we have the arachidonic acid. So that one is CH3, CH2, 18, COOH. So it continues and continues like that. So all these fatty acids I give you, they are saturated fatty acids. They are saturated fatty acid. So now when you talk of the unsaturated fatty acid, so an example of that is oleic acid. Oleic acid, that's an example of an unsaturated acid. Now let me quickly show you something. This is the structure of fatty acids. It will come in this form. So it's made up of that. You can choose to write this RCOOH. Now this R is the hydrocarbon tail. Why this head is the head? Why this COOH? That's the head. Now let me quickly mention something. Now look at, let me use it in form of a skeletal structure. Now look at it. Let's have a structure like this. So now we have OH. Now this is it. So this is a fatty acid. Now look at this, the COOH part here. This is fatty acid COOH part. Why this is the R part? Now this place is called the polar head. Polar head. Why this place is called the non-polar tail. So this is the non-polar tail. So this place is said to be hydrophilic. This is the hydrophilic head. That is, it can react with water. Hydrophilic head. Why this is the hydrophobic tail. So that's how that one is. So this is the, so when you're talking of fatty acid, so we'll discuss on that. So this fatty acid on that. So now let's move forward, having discussed fatty acid. So let's move to the structure of triglycerides. So when you're talking of triglycerides, what are you talking of? Triglyceride is made up of fatty acid and glycerol joined together in a dehydration, by dehydration reaction. That is, water is removed in the process. So now let me quickly show you something. Now look at this. We have this. Oh, sorry. Okay, let me start by saying, okay, this glycerol. We are talking of glycerol. We are talking of COH. We have H here. We have H here. We have another C. H. OH. C. H. H. OH. So now look.